All right, let's go ahead and work through this problem. And this is going to be a fun one because what I'm recognizing here is that I have something with x times something with x, which means we are going to either be using u substitution or by parts. Now, for this one, I'm going to be using by parts technique because I don't see a good u substitution. Like if I were to choose the 2x, if I chose u, du gives me 2 dx, which does not help me with my x squared in the front. So I'm going to go ahead and give a by parts attempt at this. Now, I'm going to let u equal my 5x squared, and I'm going to let dv equal e to the 2x. So we're going to take take the derivative of u, which would be du. The derivative of 5x squared would be 10x dx. Where similarly, we're now going to do the antiderivative of dv, which would give me v. And the antiderivative of e to the 2x would be e to the 2x divided by 2. Now, if you're not sure where that came from, let's go over here and do a little side. If I were just doing the antiderivative of e to the 2x dx, we'd look at this and say, well, if I knew this was e to the u, I'd have no problem because that is itself. So therefore, let u equal 2x. So therefore, du equals 2 dx. And now we can see here that to use our u substitution, we have a dx. We need it to be multiplying by 2. That's a simple fix. We're going to multiply by 2 and divide by 1/2, right? It's called the inside-outside technique. So now I have a perfect match. Everything I highlighted in yellow will be replaced with du, and then everything, the 2x, everything I highlighted in green will be replaced with u, leaving us with 1/2 times the antiderivative of e to the u du. As you can see, this was the green and this was the yellow. So now I'm going to take away the color. There we go. Now the antiderivative of e to the u is, well, itself e to the u. And then we technically have plus c, but we'll get back to that in a little bit. So it'd just be e to the u, and we know u is the same thing as 2x. So this is e to 1/2 e to the 2x, which could be written as e to the 2x divided by 2. So at this point, usually when we're this far into it, we kind of have that substitution down where we don't need to show the steps, but if you do, I hope that helps. Okay, now, on to the u substitution. Back to what we were doing. So that again was just explaining how I got this. All right, so now on to the the by parts. We're going to go ahead and say the by parts technique is u times v minus the antiderivative of v du. Right? So we're going to go ahead and fill that in, going diagonally. So that's going to be 5x squared times e to the 2x divided by 2 minus the antiderivative of v du. So that's working across this way, which is e to the 2x divided by 2 times 10x dx. So with a little bit of simplification, this 2 and this 10 are going to divide, leave me with 5. And let's just do a quick little rewrite. I'll rewrite this as 5/2 x squared e to the 2x minus the antiderivative. That was supposed to be an antiderivative symbol. There we go. An integral. 5e to the 2x times x dx. And now this is what makes this problem so interesting, is when we get to this part, we say, wait a second. I still have a product rule. I still have two things with x multiplying. But the good news is you'll notice we originally started with x squared. Now we're down to x. So if we do this one more time, if I let u, whoops, that slid on me. If I let u equal x and dv, I could let it be 5x just to be kind of hold with the same consistency that we were doing before. It wouldn't matter. You could do either place. Letting u equal 5x and letting dv equal e to the 2x dx. We do the derivative of u again, which gives us 5 dx. I do the antiderivative of dv, which would be v equals e to the 2x divided by 2. And now we go ahead and write our answer. And here's where we're going to just be very, very careful when we go ahead and write this. It's going to be 5/2 x squared e to the 2x minus, and then we're going to fill in our whole antiderivative here. So this will be 5x, this is the u times v, so this is 5x times e to the 2x divided by 2, minus the antiderivative of the across. So this will be e to the 2x divided by 2 times 5 dx. All right, now this is an amazing moment. because we look at this antiderivative that's a little funny looking. Let me fix that. There we go. I guess that's a little better. And we're going to say I don't have a product rule in here anymore. I just have e to the 2x and some numbers. So I don't need to do by parts anymore. So let's just do a quick little rewrite. All right, what I'm going to do is I'm going to take this negative and distribute it through. So this is going to be negative 5x e to the 2x divided by 2 plus the antiderivative. And here what I'm going to do is I'm going to rewrite this as 5 halves e to the 2x dx. And if we wanted to, we can use the constant multiplier rule. It says we can move this 5 halves out to the front, which we could have actually done with the 5 from the very beginning if we wanted to. But I don't know why. It just seems like a good idea to refresh, so I thought I would mention it. So we're going to go ahead and rewrite this as plus 5 halves times the antiderivative of e to the 2x dx, right? We can only do that with constants. We cannot do that with variables, but 5 halves is just a number, so it's a great time to do it. Now we do this antiderivative, and we're almost done. 5 halves x squared e to the 2x minus 5x e to the 2x divided by 2 plus 5 halves, and then what is the antiderivative of e to the 2x? We've already done it twice. Let's do it a third time. That would be e to the 2x divided by 2. And finally, we can put a plus c, which will account for all the antiderivatives that we have done throughout the entire problem. So now, if we wanted to do a tiny rewrite, what we could notice is I have a 5 halves here. I have a 5 halves kind of looking diagonally here. And then I have a 5 halves here. So I'm going to go ahead and factor out a 5 halves. So this will be 5 halves times x squared e to the 2x minus x. And actually, hold on. Wait. We also have e to the 2x, e to the 2x, e to the 2x, don't we? So why don't we take that out too? Let's go ahead and factor out e to the 2x. I accidentally erased my halves from right there. There, we'll put that back. All right, so we're going to factor out 5 halves e to the 2x, which will leave me with x squared minus, we took out the 5 halves, we took out the e to the 2x, so that'll just be x. And then I think this last one would just be 1/2. And then here's the trick for these computer algebra systems. Always put your plus c on the outside. When you're doing MOER or anything like that, they don't like it when you put the plus c on the inside of the factoring, especially because there wasn't an e to the 2x in there. So we'll write it like that. All right, so I hope this helps.